Thank you, everyone. Always fun to have the post-lunch session, but yeah, I hope you are awake, right? What I'm going to discuss is how a typical LLMOps ecosystem comes about, right? I will give you a structure, what Booking does. Booking.com has one of the biggest, actually, it is the biggest LLMOps ecosystem in the industry, and how we have structured it, how the MLOps ecosystem with the advent of LLMs, and what kind of investments we are looking for, right? And obviously, we are here, so we use weights and biases as well. Cool. So this is me. Ayush was kind enough to give me an official presentation, but unofficially, I also play chess. I used to be a chess NM. I play Go. So if you, like me, are very bored of talking about AI and ML, if you want to talk chess, you can come and reach out to me as well. Yeah. Awesome. So let's start. Uh, Basically, what we are going to do, as I told you, I will run you through a typical ecosystem, what a MLOps ecosystem looks like. With the advent of LLMs, what investment areas that Booking or any typical e-commerce organization is looking at, and I will actually cherry pick each of the areas. Yeah. Oh, amazing! Yeah. Maybe can I maybe have the mic? Yeah. No worries. Check, check. Can you hear me? Awesome. Yeah. So let's maybe start. But before we start, it's very important to clarify the terminology. You can hear me, right? Yeah. So you are a smart audience, so I won't bore you what AI, ML, and DL is, right? But these terms are thrown around a lot, so you should be very aware, right? Basically, AI is sentience, ML is basically hard pushing data, and deep learning is a smaller subset what we learned in our education, basically neural networks and everything. Right? It has been around for 60s, but I think the only thing that has changed is compute is cheap right now. Compute is easy, and that's the reason why we are talking about advanced use cases. Right? Two terms are thrown around, and I would actually like to deep dive into those. Right? Firstly, let's discuss MLOps and ops in general. Right? What does an ops layer mean? If you are a developer, you know if something becomes complicated enough, we developers like to put an ops layer on top of it. Right? Development became complicated enough, DevOps. Security became complicated enough, SecOps. And obviously, ML is complicated enough, and we have to justify our living, so it is MLOps, right? And now with LLMs, what has happened is there is something called a foundational model. It could be a multimodal model, it could be image to sound, etc. So FMOps is basically an MLOps layer for foundational models. LLMOps subsequently is a subset of that, because LLMOps is only on large language models, right? I think that is the only difference between those two terms. And if you look at Booking.com, at any point of time, if you're interacting with us on our website or on the mobile app, you're interacting with more than 400 ML models, right? We are a consummate user of ML, right? Right from your ranking to how your autofill is working. Let's say if you are in the US, you can also try out a product called AI Trip Planner, basically a travel assistant that can actually book you something end to end. Everything is working on Booking.com, right? To give you an amount of scale, we do more than 200 billion, 220 billion predictions per day at 4 nines. It's a highly scaled system, more than 400 models at any point of time. Most of the model latencies are less than 20 milliseconds. Right? It's a problem when we're working with LLMs, but if you look at the non-SOTA ML models, most of them are less than 20 milliseconds in latency. Right? Up to 3 billion training examples, so we run very big training ecosystems as one. Right? Now let's dive deeper into what a typical MLOps or model ops ecosystem looks like. Right? A typical MLOps ecosystem has two things to do. You train a model, you serve a model. Right? It's a factory line of basically your MLOps ecosystem. And if you're looking at training a model, you have two distinct differences in a typical e-commerce organization. You have an applicative layer, which is your chatbot and the front-end customer-facing application. This is a data layer, which is your basically your training set, right? And then there is a MLOps layer. An MLOps layer has these discrete components. You have a model training layer, a model serving layer, a feature engineering layer, governance layer, especially if you are in Europe, ML observability, and ML experimentation, right? Typically, before, let's say, October of last year, when ChatGPT came into the fold, this is what you used to do. This is still your bread and butter if you're working in ML, right? Uh, for all the hoopla about Gen AI, very few production use cases abound. Most of the use cases are still your typical ML models, right? And if you look at model serving, basically once you have trained the model, you serve the model. You serve the model to a customer, right? It could be an app interaction, it could be on the website, but the layers remain the same. Different layers are activated on different aspects. Not everything is activated in both production and, let's say, training. With the advent of LLMs, this has changed. So if you look at a typical consummate organization like Booking.com, we are looking at additional investment areas. So we are looking to invest in something called a wrapper. We are looking to invest in a prompt engineering ecosystem. We're looking to invest in model evaluation and optimization layer. And obviously, a lot of us know what embedding management is. A lot of investment is going into this here, right? And similarly for, let's say, model serving. Now, what I would do is I will pick each of these layers. I will give you an ecosystem, okay, what was happening right now. And with the advent of LLMs, what kind of investments we are making from Booking.com and what kind of use cases subsequently we are unblocking. So let's start with the data layer, right? I think it won't be overstating when I say that data is the bedrock of your ecosystem. If you don't have well-labeled data, you don't have lineage data, any kind of ML model you make would be worth naught, right? So any kind of data ecosystem that you have is something that you invest a lot in. A lot of VC money has already invested in this. If you know terms like data lake, data mesh, these are the kind of terms big e-commerce organizations throw around. You actually collect all your data, you actually try to streamline and you monetize your data, right? You can monetize your data via ML, you can monetize your data by actually selling right now, because data, especially with a big e-commerce organization like Booking.com, is at a premium, right? What has changed is, before the advent of LLMs, mostly what we were dealing with was structured data, right? Your ML ecosystem typically was only working on structured data, right? But now with the advent of LLMs, we have started realizing, okay, we have to start working with unstructured and semi-structured data, because the user input can directly come from a chat, or user input can be just like image input, right? So I think that has what has changed, and we are actually doing some investments in this area as well, right? But the majority of the investment in the data ecosystem is, up until now, our data lake, our data mesh was only working with Parquet or, let's say, a open table iceberg format, right? But let's say hypothetically, if I have unstructured data, how do I make sure that it is part of my data lake? This is a big question that we are facing right now. Let's go to model building training. I think this is a workhorse. Your light GPM, your production workhorses, your TensorFlows, etc. Everything is supported here, right? Before advent of LLMs, this was a pretty simple layer. You have a lot of formats, people develop things on their formats, etc., right? With the advent of LLM, what we have started realizing is there are multiple things that you can do with an LLM. And one of the things is you don't necessarily need to train the model in-house. And if you look at a lot of typical e-commerce use cases that are unblocked right now, are actually hitting a public API. And public API could be a ChatGPT API. It could be, let's say, hidden behind AWS Bedrock or Google Vertex AI, right? So you can just use it as a client API and just hit. I think that is the advent, and that's why I mentioned a wrapper, because what we are trying to envisage from a MLOps layer point of view is create a middleware behind which you can abstract away the complexity to the end user. So you can have ChatGPT hits, you can have, let's say, even Llama Index, or let's say open source hits, etc., etc. And this is a major investment that is actually going on here, right? From a model building point of view, we are open to the idea of now not hosting a model on our own. The kind of use cases you can unblock are obviously very limited, but let's say Booking.com, we have people writing reviews online. We want to summarize those reviews, right? That doesn't incur a lot of hallucination, right? It's a typical summarization kind of use case. That kind of use case could be solved with a typical middleware hit. Yeah. Let's talk about model serving. Model serving is basically where your hardware, a lot of investment is going here, right? If you have bought NVIDIA stock 10 years back, kudos. What are you even doing here, actually, right? Go out and enjoy, right? But this is what a lot of investment is actually gone into a lot of areas, right? Even for the biggest e-commerce organization, and I have friends in Meta and Google, your typical use case would never exceed 1 GPU, right? Your typical H100 used to be good for you for your year, right? What has happened with LLMs is we have started realizing, okay, if you have to something do, let's say fine tune, right? 1 GPU is not enough, right? Then you have to start investing in distributed GPU training, right? Obviously, it's not something that every organization is doing, but a big tech organization is obviously flirting with the idea of having its own LLM, right? That is one area that has got a lot of investment from a training point of view. Another area I think you're already aware is a lot of custom hardware has come into the picture. So GPU is not the only game in town. If you have AWS, you have Inferentia and Trainium. Meta has its own hardware. There's a very nice open source hardware, Grok. We really like it, right? It's as good or better than, let's say, NVIDIA in at least my personal opinion, right? So a lot of investment is going in open source. And obviously, how do we actually make sure that we can work in an ecosystem that part of my training is on, let's say, a GPU, part of it's on Grok, part of it's on Inferentia or Trainium, is something that is what we are really interested to know. Yeah. Feature engineering. Feature engineering, I think if you have worked in ML or even if you have worked in data engineering, you know what a feature store or a metric store is, right? Your typical MLOps ecosystem, what you try to do is you try to abstract away commonly used features so that a lot of people within your organization can use it, right? Before the advent of LLMs, most of the discussion we used to have on features was online or offline serving. Let's say batch features, or let's say something that is served in real time, right? I think what has changed with LLMs is we have started realizing two other aspects. One aspect is basically vector store. We have to make sure that our embeddings are also abstracted away and shown to the customers, right? The second aspect is, which is very real politic and which is very real to a use case, is something called a prompt store, right? If you have ever developed a chat-based application on an LLM, right, you know the latencies are not that good. Until and unless you are hosting it on your own, even then the latencies are not that good. So, but if you're actually developing a production organization or production app, you want to make money out of it, right? It's all well and good to be a theoretical exercise, but how do you make money out of this? You have to make sure that the prompts, commonly used prompts, are actually stored nearby in a MySQL or a, let's say, OLTP database, so you can very quickly reply to the user, right? And that's why I'm saying if you are, let's say in the US, try out something called Bookings AI Trip Planner. So we have used a prompt store there, right? This is the investment that we are thinking. If you have to productionize a use case, you have to make sure that a business use case could be commercially as well as in a good user experience way solved. And it can only be solved with a prompt store. This is at least what we have seen. The ML governance layer, if you have worked in EU, the governance is part and parcel of our life, right? But if even outside, let's say PIP and PIPL and even India and China, US, everybody's coming up with their governance laws, right? So you have to make sure a typical MLOps ecosystem has a governance layer around to it. A lot of vendors have come up with their own ML registry, etc., etc. So you can either build or buy it, right? I think Weights and Biases also have their ML registry, right? But it's very important. It's very important because you are actually showcasing this to the government. You are actually on the hook of big fines if your ML models are shown to be biased. They actually, let's say, the EU government actually flags something that, okay, this model is unnecessarily biased. And if you are a big e-commerce organization like Booking or let's say Meta, etc., you cannot afford that, right? So this was always an important thing, even before LLMs. With the advent of LLMs, this has gained even more importance. So EU AI Act is actually asking us for ML registry, the model drift, the data drift, everything that they could ask for. So even if, let's say, you are doing something very low-key, if you are exposing it to the EU customer or any kind of customer, you should be thinking about this, right? Let's talk about ML observability layer. So I think all of us are aware of what system observability is. They are your typical tracer bullets, right? With the increased complexity of both data and ML, abstracted tooling has come up on both data observability and ML observability. So if you're working on data observability, you might have heard of terms like Monte Carlo and Syphlet. There's a lot of VC investment that is going into that area. From an ML observability layer point of view, there are tools like Arise, Aporia, YLabs, etc., etc. And what they do is they actually build an abstracted observability layer on top of your MLOps ecosystem. This is only for big organizations. You don't need to worry about if you're, let's say, just bootstrapping, right? But when you're talking about MLOps, you're talking about big organizations. So we actually have to demarcate our layers, right? What has changed with the advent of LLMs is something that you would be very familiar, that LLMs are not deterministic, right? Especially if you're putting it in front of the customer, they can actually say something crap things. They can give bad information, etc. So guardrailing is very important. And guardrailing for us is done by an observability layer. Right? So you can use something like guardrails.ai, or you can use these commercial off-the-shelf technologies. Either way, you need to have a layer on guardrailing. Experimentation layer, right? Anything that you need to improve, need to have an experimentation layer. Obviously, weights and biases shines here, right? So, but there are other tools also. So there's open source tools also as well. So experimentation has been a very important part of any kind of e-commerce organization. Any customer-facing organization, you earn your bread and butter by running experiments, right? What has changed is prompt experimentation. This is something that new that we are seeing, right? Right now we are thinking about how to do it. We are trying to build something on our own, but I'm hopeful that weights and biases will do something about it, right? There's also your traditional off-the-mill like interleaving multi-model experimentation. I think those kind of experiments are even more relevant with LLMs. Yep. And then let's go back to one singular line. I don't know whether you noticed this or not. It's very nondescript. But if you are a fan of OpenAI or DeepMind, all of their investment is in this area, basically feedback loops, right? What does feedback loops do? For a typical e-commerce organization, our roles are not that ambitious. We are not trying to build AGI. What we are just trying to do is collect real-time information or batch information. So label collection, etc., is what we do with feedback loops, right? But if you look with the advent of LLMs, what RLAIF, RLHF, everything is happening on feedback loops. Basically, agentic flows can only happen from feedback loops. A self-prompted ecosystem or a human-prompted ecosystem, the investments are all in this area, right? But for a production organization, we don't go that deep. We are very happy with, let's say, a simple feedback loop. And yes, let's come to model evaluation and optimization. Now, what has happened is the reason why we are trying to invest in this area is, and I think the reason why weights and biases is also investing in this area is, with so many models out there, how do you evaluate, let's say, whether a Flan versus Falcon is good for me for my summarization use case versus Claude 3 versus GPT-4 Turbo? How do you can actually, let's say, compare A versus B on this parameter, right? It could be a custom parameter or it could be a standard parameter like toxicity, bias, etc., etc. So a lot of tooling is being developed in this area because you actually want to finalize on a vendor, finalize on a tool, a LLM model that you want to use, right? So that is the investment that is going on the model evaluation part. The optimization part is, as I said, right, we are an e-commerce organization. If you're trying to build a production profitable business, you want to make sure you're optimizing on both the deployment in terms of money, in terms of cost, right? And how do you do that? Let's say if you're using GPUs, NVIDIA offers a lot of tooling such as, they used to be called NVIDIA Triton, now they have deprecated it. Now NVIDIA has something called NeMo microservices, right? And I think more than the hardware, this differentiates NVIDIA. The software stack of NVIDIA differentiates it, right? A lot of people are doing very good hardware like NVIDIA, but being capable of actually optimizing on, let's say, a GPU in 1 hour, vis-a-vis deploying it in 11 hours is very important for a profitable organization, right? We are not in here for research. We are here actually for making money. And that's why this is a very important aspect, and that's what we are investing here. Cool. Summarization, I think everyone is aware that, okay, these are the 3 things you can do. You can either directly hit an API, we discussed wrapper, right? You can just sort out your use cases using prompt engineering, text summarization, etc. are done by this. Or you can give a quasi memory to your LLM, and this is what embedding management is done, a typical RAG flow, right? Or if you have deep pockets, you can just fine tune your own model, right? But yeah, and what's actually the latest thing that we are seeing is not LLMs, but SLMs, small language models. So if you know what Microsoft is doing on 5.1, 5.2, 5.3, Google is doing with Gemini Nano, you have these small models which can actually be deployed on my phone, right? So it's like an SDK, right? Something that can optimize on a typical Samsung phone, right? It can actually act like an SDK, collect information, hyper-personalize me on my mobile as well. A typical highly tuned small 1 billion parameter is much better than, let's say, a 7 billion Llama 2 or something, right? But hyper-parameterized for one particular application, right? So this was me. I hope I didn't bore you, right? Yeah? Awesome. And thank you so much, and thank you so much for spending your time.